Okay, so we had the front-end internals before. Now let's go a little more in details. What happens on the worker nodes themselves? Okay, so since we had a long lunch, just a reminder, the glidins are just properly configured Condor daemons, and the glidin setup is the one that configures the starting one. So let's start with rehearsing what we said before, that the glidin startup downloads script, parameters, and control binaries, then validates the nodes, essentially the environment, configure Condor, starts the Condor daemon, goes to sleep. Once Condor is done, collects post-mortem information and does the cleanup. Now, the files are downloaded both in the factory and the front end using HTTP, using the local web proxy available, and do it in a secure way. Now, how the glidin startup knows where to go for the web servers? It's one of the arguments. So the glidin startup is given the two web servers URLs from where to fetch all the other information. So if you assign, you actually see them as an argument for the pilot. It also tells it if there is any split or not, and the various arguments define the factory. Everything goes by delegation. So the front end delegates the URL to the factory that sticks it in the Condor G job. So, cache coherence. You know that if you use any kind of caching, making sure that new files don't get forgotten, you want some cache coherence. And in the glidins, this is done essentially in such a way that files never change. So once a file is put on the web area from the front end, it will never change. So if you need to change anything in the file, you create a new file with a different name. So you're guaranteed that anything that has been cached in Squid, it's valid essentially forever. And you don't have to worry about that. And then the file itself, it's referenced in all the other files are referenced in a map file, so that you can find the logical to a physical file name. And the map file itself, it's versioned, so the versioning of the map file is actually referenced. It's passed as an argument to the glidin startup. Yeah, that's it. So how instead make the files tamper-proof? You probably know that HTTP is not really secure. You can hijack it. You can you could poison the cache or whatever. So you want to make sure that things get secure. And we use SSH1 caches essentially to do that. So each file has an SSH1 cache attached to it. And after it is downloaded, it's checked against this hash. If the hash is not valid, the glidin will go away and say, whoops, something is fishy here. In more detail how it's implemented, again, everything, all the hashes go in a single file called the signature, and this is versioned as everything else because cache coherence. But then the signature of the signature file is passed as an argument. So it's essentially hierarchical. So we have a file that contains all the other hash values, and then the hash value of this file is passed as an argument. This way, you have the whole integrity check of all the files. This way, with a single argument passed to the glidin startup, keeping the argument line reasonably short. You may wonder why we don't use HTTPS, and this is essentially for two reasons. One, it's pretty much impossible to cache HTTPS, and two, it's can be an overhead on the web server. We prefer to have the overhead just on the worker nodes. So the web server is lightweight. It just serves files without having to decrypt everything at a single time. So here is in great detail how it looks. If you do an LS of your stage area on the front end, you will see something like that. And this is how it works. Essentially, you have these two files where everything starts with. And the argument of this one is given to the gliding startup. So it fetches this one, downloads the signature, validates it through the hash it was passed as an argument, revalidates again that the hash of this one is correct, and then starts downloading all the other files and validating the hash files. So this is just a high-level overview. If you look in your stage areas, you will see stuff like that. You know how they relate to each other. So one important thing that the gliding startup does is not validation. So validation is a dump here. The gliding will run scripts and plugins provided by both the factory and the front end, and there is a map file that tells you which files that have been downloaded are actually scripts and which ones are just plain files that are just delivering values and do not need to be run. So there is a file that has a mapping, which is called, I think it was here on the previous slide, the file list, and there are a couple depending in which order they run, and they contain lines like this. Essentially, the logical name, the physical name, and what type of file it is. If it says regular, it's essentially do not run it. If it says exec, it's a script, run it. If it says wrapper, it will be passed to the Condor to run just before the job starts. And for all scripts, if a script returned with exit code different than 0, it assumes it failed, and the gliding startup stops there. So it will not try to download or execute any other scripts. It finishes there, and it's done. Condor will never start, jobs will never get to the worker node. It usually starts, actually sleeps for another 5 or 20 minutes. I think it's 5. I think that should be 5. Or 20. A few minutes before going away. The reason being is that this node is supposed to be broken now. So if I were to go away immediately, I would probably get another glidin here immediately, which would fail and go away, fail and go away, fail and go away. So we want to waste some CPU so that the glidins that are in the queue have a chance to actually be matched against good jobs and actually get some glidins running. So while this is a waste for all practical purposes, we assume that if we start another gliding here, it will fail again. So it will be waste in any case. So we lower the stress on the side batch system without really losing much. And it really reduces the black hole effect. So glidins actually have a fleeting chance to match against good jobs and not be eaten completely by a broken node. Another important thing that the gliding startup must do is configure Condor. We said glidins are just properly configured Condor daemons. So this is one of the most important parts of what the gliding startup does. And the actual configuration values come from the downloaded files. They are both static from the factory and the front end, and there is even some that can be passed as an argument. We get more details here, and we will have dedicated talk tomorrow what we should do there. Scripts that can download it can add, alter, or delete any attribute, any standard or not attribute, based on static or dynamic information, whatever you want, that can be either discovered from the worker node or delivered through the front end, or combined information from other scripts that ran before, whatever. And again, you get more details here, and we will have dedicated talk about this. And this is right now just so you know it is possible, and you actually should consider it. So here is an example of a pseudoscript. So what it does, looks, does CMS software exist? If it doesn't, fail the validation. I know that my jobs will need the software, CMS software. If it's not there, just fail. There is no reason to stay here. There is no sleep here. The sleep will be done automatically by gliding startup, so you don't need to worry about it. Fail as soon as possible. Yes?
Dumb question. Let's say these standard output of this script, does it go to the factory logs on?
Yeah, it only gets to the factory. There is no way to get it in the front end right now. There is some work being done for that, but right now it gets only to the factory. The factory admins will look into that and if needed contact you.
So you would have to iterate with the factory people to test things.
Yeah, it's not ideal right now. And I have something more in the tomorrow's talks. But yeah, good point. Assuming things worked, I get here, in this case, let's say, just source this setup script, and let's say that defined a variable that's called CMS software list. So I get it, and this essentially says publish it to Condor. We have in the tail what it means semantics, but assume this says publish it to Condor, and then I exit with Condor exit code 0. I'm happy. Validation succeeded. I did the configuration I want. So I want you to run the next script or start Condor if this was the last script. Again, more tomorrow, but just to get a feel of what's possible. As I said, you can also provide attributes directly, statically in the front-end config. And the classical example is a start expression. I mentioned it before. You may want to provide a start expression that goes into the configuration of Condor so that the matchmaking of the front end and the matchmaking of the negotiator via the requirements of the startee are in sync. So, for example, you would define gliding client group start, and this will automatically then be ended with whatever the factory provides and given to the startee. This is one of the few standard variables that are available. If you go here, they are listed. And it can get complicated as you like. Here is it. Again, a long one, so you see it. It doesn't need to be trivial. You can send any attributes you want to Condor. Once we have gone through downloading all the files, running all the scripts, the final step is to actually get this information into Condor config. That was done as one of the scripts. At this point, Condor master is it started, which will in turn start the Condor startee. Just a regular Condor from here on. This starts the startee, this goes to sleep. This is out of the picture until this is done. There is very little that's actually active doing something. The only thing that currently does is intercepts any kill signals so it can pass it through soft kills that can pass them through Condor. But that's about it. It will not do anything else. It just really waits for Condor. So it does the usual stuff. Talk to the collector, negotiator can do its job. Schedule can talk to the startee, jobs can start. This all happens without any intervention by the gliding startup. It's completely out of the picture. After Condor startup goes away, it actually parses the Condor logs to see what happened. It essentially extracts how many jobs it ran, how long they ran, which users they were. It essentially does some pre-processing so that further on monitoring is simplified. And that process information together with the complete Condor logs, which by the way get compressed so that consume less space, but they are still there, get shipped to the factory through Condor G. And nothing gets to the front end. there is, as I said, work in progress that we may propagate something to the front end. Right now there is zero, absolutely nothing. Yes?
So the exit code that you send out after you're done with this, is that the jobs that were run in the gliding, does that affect the exit code
No,
of the gliding?
at all. The exit code the grid side gets, it's the exit code of the gliding.
Right,
Essentially, did Condor start or not? So the exit code is did Condor start or not? Doesn't matter how jobs ran.
what about preemption if the gliding gets preempted?
If the line gets preempted, it's killed, so it cannot have any exit
How
code.
about the signal? You said you did signal handling.
I think that's still considered to be a good thing. So Condor did start, Condor did end, and the exit code should be zero unless we have a bug. So yeah, and again, also the exit code, if the grid protocol is supported, gets back to the factory. Nothing gets to the front. So if anything goes wrong with the gliding, the factory admins are the only one to know it, which is sort of the right thing to do because anything that is grid related is supposed to be handled at the factory, and the front end should not worry about it. The front end should only be worried about things after the start is successfully started up and talked to the collector. Only the Condor part. Of course, there are edge cases like the VO validation script fails. How do you know it? Jeff should be particularly good in catching that and telling to you. Of course, it's a mess when you first develop them, but in a steady state, it should not be a big deal. But yes, I agree that we need something better, especially when you try to improve things and make incremental changes. Not having to talk to Jeff every single time would be more efficient. But steady state, it actually should be pretty well. And you can tell us that it's not at all true between Thursday and Friday. And finally, after the monitoring is done, the gliding startup will remove all the files that were created in his working directory so that it's a good citizen and doesn't leave anything behind. Of course, unless it is killed by the OS, in that case, cannot do anything, it's been killed. And unless user jobs write into unusual locations, it is CD to any random location, we cannot know it, we cannot catch it, we cannot clean for them. So as long as jobs are well behaved, we will do the right thing and clean up. And Condor does a similar thing between each and every job. So bottom line, users should not expect anything to survive between jobs and between glidins. If anything, by any chance, remains between jobs and between glidins, it should be considered a bug, and it's strongly discouraged. A few words about glidin lifetime. You should also always consider glidins a temporary resource. They must go away after some time. You are not, every time glidins is started, you cannot expect to be yours forever. We want them to, sooner or later, whoever started your gliding will kill it if you don't go away by yourself. And we want to go away by ourselves, because if you go away in a nice, clean way, you can do something about it. So you can monitor the progress, clean up, and you can not, for example, start new jobs that you know will not be able to finish in time. Stuff like that. When you are killed, all bets are off. You're gone. You have no say about it. So Condor daemons can be configured to die by themselves. You just need to tell them when, and the next few slides should be about that. So how do you specify how long the gliding should run? You can have a hard end of life deadline, which is essentially the moment where Condor will terminate anything if it ever reached. And any jobs that are running at the point will just kill. And you arrived at the deadline. Bye. I don't care what you have been doing. You have to go away. Which is of course a waste. If you ever have any jobs that were running when you reach a hard deadline, they will be killed. So unless they have been checkpointing like crazy, there will be some waste of CPU. And checkpointing is often wasteful by itself, so not a good thing. The deadline is set by the factory, and it's site specific because we know that different sites have different policies. So some sites may allow you to run for 48 hours, and we have some queues at some sites that are 4 hours long, which some people claim they can fit the jobs into, so we support them, but most of them are around 2 days, and with very few exceptions that are a few days longer. But that's again not something that the factory can really decide. We just configure it in such a way that we live within whatever the site supports. And this is advertised by the factory as gliding max wall time. So when you do the matchmaking, you actually know what is the max you can expect, and you should subtract something from this, because this is really the maximum that you are allowed from the moment you start, and you probably, the moment the first job starts, you have already lost a few seconds, if not a few minutes, because of starting up validation, matchmaking. So you should subtract a reasonable amount of this. And once the gliding start, they will advertise an attribute in the start class ad that is gliding to die. So this is the Unix timestamp where the gliding will go away. So when you do any kind of matchmaking, you want to make sure no jobs are dead. That's what you want to refer to make sure you never reach it. As I said, starting jobs just to kill them is wasteful. So if you may not have any information how long the jobs are supposed to run, try not to start jobs that are likely to be killed. Actually, that's the next slide. The glidins themselves do something automatically, so that you don't need to do it explicitly. So the glidins will stop accepting new jobs after a soft deadline. So once the gliding gets beyond that soft deadline, no new jobs will start. And this is advertised, gliding to the trying time. And the problem is you need to know what is the typical lifetime of a job to set this to the tie, right? It must be somewhere before the hard deadline, but how far in advance? You want it to be set to something that is about the typical lifetime of the job, so that you are not going away very fast. I could put it to pretty much infinite, so you have 10 seconds to match or nothing will start. That will not work. Or I could put it really close to the deadline, and then essentially every job will die. So you want to put it something that is about an average time of a job, or where the majority of jobs will finish in time. And this is defined by the gliding job max time attribute. And we expect this to be set by the frontend, because different VOs will likely have jobs of different types. And while we provide default that is reasonable, it may not be reasonable for all the VOs. So VOs are really encouraged to set it to whatever they expect their typical jobs will do. And then this is the actual formula that is used to calculate what the two-letter is. Yes?
Does this time applied across all groups or all front end, or do we have different groups with different times?
You can have different groups with different times.
Okay, so we may have different types of jobs.
Yeah.
Okay.
So, and let's see if the next slide. No, okay, the next slide. Yeah, final grain policies. You can do something better than this. This is the basic stuff that the gliding does for you, so that you don't have to do much. But before I get to that, let me add another piece of information. This is that glidings will self-terminate if not used. So if you have a gliding that is not matched for a certain amount of time, it will go away by itself. because anytime a gliding is not matched, it's a waste. Because having a gliding running, you're still built against the grid-based system, but you are effectively wasting CPU because Condor is doing nothing. It's just waiting for a job to come in. So in order not to waste too much time, if I'm not matched for a certain amount of time, I'll go away automatically. The reasons for being not used is no more user jobs are in the queue. For example, a user submits 10,000 jobs, 1,000 glides get started, each run 10 jobs, no more jobs in the queue. All 1,000 glides go idle because there are no more jobs. And unless user submits more, there's nothing you can do about it. The jobs are 10 seconds long, yes. After 100 seconds, all 1,000 jobs are idle. Should not happen, but it does happen. Depends what kind of activity your users have. But there can be also policy problems. For example, as I said, it's two-level matchmaking, right? One's the front end and then the negotiator. So if the front end decides to send glidings to sites, and then the negotiator says, I don't match any jobs to this, you may get in this situation too. So this is actually normal and healthy. You cannot do much about it. Spikes are spikes, unless you want to start one gliding at a time. This is actually healthy. This is a real problem, so you will need to look after this. And tomorrow when I talking about monitoring and troubleshooting, I will stress that again. The self-termination is typically uniform across the pool. It can be set by either the front end or the factory. The default is 20 minutes. If you want to change it, set it to gliding max idle to something else. People typically don't just live with the default 20 minutes, but if you know you have very spiky users and very responsive negotiator, you can actually reduce it by a lot. I think you don't want to get it below 5 minutes, but you can try and see it. If you get a lot of glidings that start and are never matched because the negotiator doesn't get to matchmaking fast enough. So 20 minutes is a safe bet so that there is enough time for the matchmaker to do its job. Now, final grain point. So you have a wide variety of jobs with different lengths. So and a single job max time doesn't really fit your needs. If the spread is not too bad, just set it to the max one, and it actually works pretty well. If your max job lifetime, if you have jobs between 1 and 6 hours, set job max time to 6 hours, and on a 48-hour batch slot, it's actually perfect. You don't have to micromanage it. But if your jobs are between 20 minutes and 23 hours, well, you don't want to set the job max time to 23 hours. You will need to do something smarter. So in that case, you just use the standard matchmaking to define fine-grained policies. We have it on the next slide. Yeah, there. What you want to do is essentially use the information in the class set and of where is the to-die lifetime, deadline, where is what is the expected job lifetime, if the job defines it in the class set, and do the matchmaking. So even if you haven't reached the to retire yet, you can still prevent a job to match to that gliding by simply setting the start expression in such a way that it will not start a job that is expected to last past the deadline. And you can use a similar mechanism to not match a very long job to a very short site. If you know that you have sites that can only run, that will only run for 4 hours, you don't want to send 24 start glidings if you only have 24-hour jobs in the queue, but you may want to start glidings if you have lots of 10-minute jobs in the queue. So use the standard matchmaking both at the gliding and at the front end matchmaking to decide where to set glidings and when the glidings start up, which jobs to match to them. So the matchmaking policies can be as complicated as you want as long as you are able to read them back then. But apart from that, sky is the limit. One is Python expression, the other is class adds, and both are pretty much, if not Turing complete, close to. So Of course, if you define a start expression that will only match short jobs and you run out of short jobs, you may end up that a glidein will finish a job and then will not be able to start the next one. And we'll have to use the idle deadline to go away. There's currently no way to say, I don't match any job, go away immediately. You will have to wait for the deadline to go away. So which is not too bad if the gliding has already run for a long period of time, it gets infraction, but it still can be a problem. As I said, you can try to lower this, but there is only so much you can go down before you actually have the opposite problem that the negotiator doesn't get to it fast enough. We had a discussion with the glideinWMS team to have two deadlines, this idle self-termination. One is the first one and one for the next ones. So that the first time you actually want to wait, if you have no jobs that match immediately and you remember the claims initially. So as long as you keep the claim, jobs will continue running and this can be set to 0 because it's not considered. So the moment the claim is broken, it has to go back to the negotiator. You can make this very short or even 0 really. The moment the claim is broken, go away, because it means that the jobs you initially were matched to, that you don't have any more in the queue. So you could set a policy that go immediately away, so 0 waste time. Or you can set it to a short period of time, and if it doesn't go to the matchmaker, oh well, you have already done at least one job, so it's not that wasteful. But right now you cannot really do it. There is only one direction. There is really only one, and it's the default alternative. However, the biggest problem is that job lifetimes can be difficult to know. Users typically don't really have a clue how long the jobs will run. They can provide some reasonable defaults, and if they can, you should encourage them, so you can at least do something about it. The other option is that you can refine them after it starts. So a user can say, typically I will run 8 hours, and you put it in a slot that has 9 hours left. After 9 hours, it gets killed. Condor will try to restart it again somewhere else, but you can automatically say something like, well, it was killed, it didn't manage into the 8 hours. Next time I try to start it, I will assume it will run for 24, so I really only will match to long queues because the user had no clue. And you could even do something like run cron scripts and correlate between user jobs based on the past experience. It's a tricky business, but it's not impossible. Using some historical information to guess what the users are doing may be useful. And however, sometimes it's really different jobs have different lifestyle times because of what they're doing. So one thing that we have done in CMS is that for each job we define two values. One is the normal max workload time and one is the max workload time. So the normal workload time is what we expect the vast majority, let's say 90% of jobs, to actually fit into. And this is usually relatively small. It's something like 6 hours. But we know that we have a long tail effect of healthy jobs. Forget about the misbehaving one. But we have a long tail effect of the healthy jobs that can last up to 24 hours. And so we try to fit jobs in the at least 6-hour slot on the glidins. And if they get killed, the next time we really want a 24-hour slot. And this is the expression to set it. So essentially you say, what's ever vacated, which means, is this the first time it's running? It's trying to be run. Okay. Try to fit it in at least the normal max workload time. Was it ever killed? it was killed for whatever reason. I assume it's because they didn't make at the time. It may be other reasons, but it's good enough. You can make it more complicated if you want, but it works reasonably well. In that case, we go for the big interval, and there will be way less glidins that match this than this. So the second time you will have to probably wait a little longer to get in the queue, but you have a much higher chance of succeeding. And then if this doesn't work, we have a periodic remove to actually kill them. We remove them from the code, from the queue, because they will not match anything. They are just pathologically broken. So what else could go wrong? Well, glidins might stay within the limits of the resource release, which one thing is the time, right? If I stay with it longer than what the site tells I can stay, then I'm pretty much guaranteed that I will be killed. But another thing that is often limited is the amount of memory you can use. I know of many OSG sites that if you use more than 2 gigs, you will be killed. It's pretty much guaranteed. So in the factory, we actually advertise an attribute called gliding max mem MBs that tells the front end how much memory a job can use. We get this information essentially in a mix of what we get from the information systems and actually because the site admins told us that it was like this. So if a job actually tells you that it needs a lot of memory, you should only match that job to sites that advertise a value that is high enough. Of course, often jobs don't know how they use, but if they do know that they use a lot of memory, you should try to optimize it. Because if you don't, the site will kill the glidin together with the job, and whatever has been done until then is lost. So you want to avoid that as much as you can. And sometimes you just don't. You can't. If you can, try it. So how, again, same story as with the work log time. You can, if the users don't tell you how much they use, you can refine it as the jobs restart. So the first time, let's try it. If it gets to the end, good. If it doesn't, the next time we know how big was the image size. And there are some other memory-related fields you can use of that job. And if it reached past certain size, it was killed due to memory. So don't start it again. And this is how you do it. You can even be proactive and actually kill them the moment they hit that limit. Preempt should be the right attribute, right, in the starting to kill a job as soon as it reaches that limit. Hopefully the image size is not going like this, because in that case Condor may not be able to catch it before the site catches it. But yeah, that's a good approximation. Now a few security considerations. As you may expect, this and this will very likely be on different part of the continent, if not of the world. So you definitely want to make sure that this communication is secure. And again, everything is GSI based in the Glidein world. And the collector and the start D essentially must whitelist each other. So the GSI magic will do its work in checking the public keys and stuff like that, but the actual authorization, which is who can talk to whom, is in your hands. And essentially it's based on the DN strings. I hope everybody is familiar with X509's way. The nice thing is that the sked D and the start D don't need to be mutually whitelisted. So you just do it in one place. And the reason is that there is some indirect authorization. Because the start deed trusts the collector, the sked deed trusts the collector, or the collector trusts the start deed. A security token is passed to the sked deed so that the start deed trusts the sked deed due to the security token that the collector got to it. It also speeds up authentication between the two quite a bit, which is nice. From the practical point of view of configuration, this means that you have to have all the pilot credentials whitelisted here, and you don't need to worry about it here. So it's just easier at least. Now, a word about multi-user pilot jobs, which essentially means you have a glidin that starts with a proxy that is not representing a specific user, let's say CDF. And there are a few exceptions to this. For example, in CMS, when you have organized reconstruction, whoever submits the pilot is actually running the actual jobs, but that is not typical. More typical is that the glidin is submitted with a generic credential of a pilot, and then you have hundreds of users that use it. And there is no relation between the pilot and the actual user. One day maybe user A, the day after will be user B, the day after will be 300 users running it at the same time, possibly on the same glidin during the lifetime. There are three potential security issues with that. One is that the site doesn't know who the final user is, and this may either violate his policies because they need to know, they want to make sure that no Iranians are running, classical example in the US. So the site may have a legal responsibility to know who is running. So from the security point of view, policy point of view, if they don't know, they cannot really allow you to run there. If two glidins land on the same worker node, two users may be running with the same UID. So as you know, most current worker nodes have of the order of 20 cores. So it's likely that at least two glidins of the same PO will land on the same worker node. Because they use the same pilot proxy to get in, they will run the same UID. When they pull in two users, they will run exactly at the same UID. So user A can do harm to user B, and user B can do harm to user A, still proxies, whatever. Name it, you can do it. There is no protection between them. And third, in my opinion, even more worrisome is the user and pilot run, or glidin, run as the same UID. So the user can actually interpret the glidin, steal its proxy, start another start deed, and start fetching other user jobs. You name it, it can become anything it wants. There is no restrictions, no protection. So if you don't do anything, it's not a good thing. You should not really do that. So why are we still selling glideinWMS if we think it's completely broken from a security point of view? Well, because there is a way to actually fix it. And what you really want is UID switching. So you want to be able for the glidin or the pilot, whatever you want to call it, to change UID when it gets a user job. And glideinExec can do exactly that. And glideinExec is standard with OSG. It's an optional piece of software for sites, so not all sites have installed it. Fortunately, it's still not the majority that have installed it, but there's a significant fraction that did, and it works nicely for them. And it's standard, you just get it from OSG stack. So as I said, it must be installed by the site. Unfortunately, we cannot do it in the glidins themselves, like we provide Condor, because this is set UID executable, and changing UID is something that the site wants to control. This sucks. But once they install it, you should use it. And the only, let's say, problem with glideinExec is that it requires a valid proxy from the final user to submit nodes. So if you don't have users that have proxies, then you cannot use glideinExec, and that's annoying. So you need to gridify the users if you haven't done yet, in order to get the security benefits of GLExec. Because else the jobs will not match. As I said, it's not a problem for a long time with users like CMS or CDF, but maybe for other BOs, I know Glow, their users don't have this certificate. So right now, they're not able to use GLExec. And I think they're very vulnerable right now because of that. There are some talks in OSG and the grid community at large to have something alternative to GLExec that would do something similar and possibly not require user proxy, but it's not there yet. Yes?
So isn't it true that some sites have glideinSec, have it set up that they don't really switch UIDs, they only do it for logging?
Yes, they can install it that way. I don't know of any in the OSG.
So all of them are doing true UID
yeah.
switching?
I know that some sites in Europe has been playing with that, but I know that even Europeans are pushing for changing that, so that the log-only mode will not be at least recommended, if not forbidden. Because there is really no good reason to have GLExec if you don't do UID switching. The UID switching is what really GL is advised, so everything else is icing on the cake. So here is just to have a nice picture view of how it works. Essentially, the gliding gets in as a user A, starts the start D, does the usual stuff. The user has submitted the SCAD D with his, let's say, two users. This one gets matched. Its proxy gets delegated to the start D. The start D uses the user proxy to call GLExec. GLExec will start the job in the user UID. So the job has no way to attack the user, but the gliding. But the gliding can still go to the job anytime because it has the user proxy. Also the nice thing is that if you have two users running on the same node, the GLExec will map them to different users. So if you have two jobs running on the same worker node, but for two different users, they will run under different UIDs. Of course, this assumes that the sites have done the right thing, has one account per user and not group accounts. But that's going into another workflow, and it's a generic grid problem of people actually using group accounts on their sites. Bad idea. And I want to stress that it's in the VO best interest to use GLExec. I mean, I know that GLExec started because, I make names, Fermilab, a site, said, we want GLExec because we definitely need to know who is running, blah, 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 blah. But that's not the real reason why somebody should use GLExec. Yes, if a site wants it, you should use it because you want to be a good citizen. But it's not the, GLExec is not really for the sites. GLExec is really for the VOs. Because if you don't have VO UID switching, you've seen the two things. All users run under the same UID, including the pilot. So any misbehaving user will bring down the whole VO. Which, unless you share bank accounts between all the users, you should be worried about. So it's the only way to have a secure multi-user pilot job system. So you should strive to get to the point where you use GLExec all over the place because it's in your best interest. Else, the first time you have a problem, you will have to shut down the whole infrastructure for weeks until you figure out what the heck went wrong. So, again, it's up to the VOs to actually push the sites because, as I said, most sites don't care, and they're right, they should not care. It's not, GLExec is not there for them. GLExec, it's really something the VO needs. And it's just an annoyance from the site, it's just a service the site provides, like they provide us. They may find out that there is some side effects that they like, but it's not the main reason. Of course, there are some sites that require GLExec for their own interests, like to cryptographically know who the final user are. It's maybe a legal requirement, or they are just paranoid or whatever. And it's easy to ban users. So if they figure out, a user is doing something bad, I just prevent him to start. That's an easy way. Unfortunately, Condor really doesn't like being told no by glexec. So if you are site admin, don't ban the user, talk to the VO, because else yes, you will prevent the user to start, but you will create way more trouble than you have solved. Condor will become a denial of service machine for you. So don't do it. And yes, Todd, we need to fix that. And they know it. In the pipeline. So how do we turn on glexec as a VO admin? Easy. You say glexec use either optional or required. But before we get to that, the factory actually advertises if a site provides glexec or not, and it's this attribute glexec bin. If it says to known, it means it doesn't provide any glexec. If it says anything else, and currently the two things you will see is OSG or glide, it means glexec has been installed. It can be used. You don't really care what it is as long as it's not known. And the front end decides if it should be used or not. And this is the thing you control. And if you say never, it will not use glexec no matter what. Even if it is available, it will completely ignore it. If you say optional, it will use it wherever possible. It will still match sites that don't have glexec installed and run without glexec on those sites. Which, if you are not too worried about security or a transitional period, since glexec is not deployed everywhere, it's better than never. But if you are really interested in having a secure system, you should put it to required. Which means the front end itself would only match sites that have glexec being set, something that is not known, and you are guaranteed that glexec will be used on all the sites where the gliding start. So this is, we should get here eventually where you only use sites that have glexec and use it there. But I think you cannot really get here. At best you can do this because a large fraction of OSG sites still don't support glexec.
So the problem is not turning it on, the problem is getting everybody has to do.
As I said, yes. For people like CMS, it's not a big deal because they have it, and especially if you do any grid data transfers, you need it anyhow. Because if you want to do grid FTP from a worker node, you need it. You will probably need the grid certificates anyhow if you do anything fancy. But as I said, I understand that some VOs that don't have fancy needs may not like it. And as I said, OSG is looking at ways to get something that is not glexec, that will work without grid proxies, but that's still just talking about it. But we should get there eventually, because yeah, if you don't care about grid FTP, there is no reason to give a proxy to the user, because he will not use it. But right now it's needed just for glexec. Yes.
So if you're already set up to have group accounts,
Yes.
is there actually a way to transition without you breaking everything for weeks?
I don't know. It's easy if you don't have anything in the queue. You just change it.
No, but I mean, if you're a production VO, I mean, like, so it feels a little bit like we have dug a hole,
Yeah.
and it's pretty much impossible to get out at this point.
Well, the group accounts are per site. So you could shut down one site at a time. So losing a tiny fraction of all the resources you have, and in several months.
But you would have to push out the new, what's the file called? The new VO package.
Well, that's just the default. Each site can change independently of that. That's just the default. Each site is free to change that any point in time. And even if you push out the new VO package, I'm pretty sure the sites will not change, whatever is already there. So sites will still need to do it by hand. Yes, it was a bad decision to do it in the past, and it will be a mess getting out of it, but we should try to get out of it eventually. And it's nothing to do with the glidens, but yeah, it's a mess that the grid thing.
I mean, it does have to do with it because if you already have a pool account, this GLXX discussion, I'm barely listening, right?
No, pool accounts don't help by themselves. You need pool accounts and GLXX because else everybody
But
will
if
run as a
there's no
pilot.
way if there's no way for us to switch away from a group account, then the GLXX discussion, I mean, why should I push for GLXX if I can switch to pool accounts in the first place?
Well, it's not that difficult to switch to pool accounts, especially if you say that anything that with the pilot role has a pool account. That can be done like this, because you don't have already an account there, so that will just work. I know you have to talk to each side, and each side has to do it, but it should not be a big deal. It just takes some following up and harassing every single side till it does it. But yeah, it's possible. It's just one-time expense that one needs to do. And as I said, it depends how worried are you. Can you afford that if you have a security breach, you can shut down for 2 weeks or a month or 2 months? If yes, then yeah, you may not care about GLXX. If no, you should start thinking about doing it now because it will happen eventually. That you will have a bad user that will do something really stupid. Not outright malicious. And that's all I have about the gliding internals. Yeah. Down this.